Morning, guys. We're at section 13.3, which is just radical functions. That is functions that include a square root, cube root, fourth root, or whatever. Today we're going to be looking at square roots and cube roots. So what we're going to do is we're going to move right along here. And today, that's our lesson. We're going to do day one. There will be no assignment today. But your assignment for today at the end, you'll see, is to make sure you have 13.1 and 13.2 homeworks done, so that you can complete an adequate formative assessment tomorrow in its learning. Okay, so what I want you to do here is I'm going to hit pause, and we learned that inverses occur when x's and y's are switched around in the graph of a function. In the functions below, we are going to switch or transpose the x values with the y value and solve y. And we are going to find what the inverse is. All right, so I'm going to hit pause, and why don't you go ahead and do number one and number two. Okay, so we're back here. Well, hopefully you did these two warm-ups. All I did was I made every y an x and every x a y, and then I solved for y. Now remember, anytime I'm taking the square root in an equation, when I'm taking the square root, there is both a positive and a negative root of it. Remember, x squared equals 9, well, that's negative 3 squared equals 9, and 3 squared equals 9. Both of those make a true statement, which is why there's both a positive and a negative root. Number two, I switch all y's become x's and all x's become y's, and then I just solve for y. So all I did was subtract 1 from both sides, x minus 1 equals y squared, then I square root. Again, there's a positive and a negative, and I'm square rooting the entire side of the function. So now we're going to do a little exploration of square root functions using the same approach for finding inverse functions as we did in the warm-up. Try to find the inverses of these three functions, okay? It's all orders of operations. So what we're going to do is really we're looking at y equals 4x squared. Then we're going to switch x's and y's. So then I'm really looking at x equals 4y squared. Then we're going to solve for y. Well, I can't square root yet. I got to get my y squared alone. So I'm going to divide both sides by 4, and I'm going to get x over 4 equals y squared. Now I can take the square root, but remember there's a positive and a negative root. So y equals, and this is going to give me plus or minus the square root of x over, not 4, it's going to be over 2. Okay? And we'll talk about this here really quick. And just remember, when you have the square root of x over 4, that's the same as the square root of x over the square root of 4, which is the square root of x over 2. And that is how I got that. So what I'm going to do is I'm going to hit pause, and why don't you do number 4 and 5 and answer why a plus or minus is needed in front of the radical to write the inverse of the functions. Okay, so we're back at number 4. I switch x and y again, and the first thing I need to do is add 9 across there. So I get x plus 9 equals y squared. I then square root. Remember, square rooting, like I did right back here. When I do that, I get a plus and minus on the opposite side of what I'm actually square rooting. That's why it's plus or minus square root of x plus 9. Now, number 5 is a little bit different, because before I can get in here, I need to square root, because the square root gets rid of that squared. That's why it's plus or minus the square root of x. Then I got to subtract 3 over. That's why it's plus or minus x minus the square root of 3 equals y. So there's actually two parts of the graph that's coming out of here. And you'll see what I mean here in a little bit. Why is a plus or minus needed in front of the radical to write the inverse of the functions? Well, that's because there's two parts of the function when you take the square root. There's the positive root and there's the negative root. And we need to make sure we're including both of those, all right? So we're going to say, given the function f of x equals 4x squared, its inverse was found on the previous page to be this. We did this on the previous page. So what we're going to do is use Desmos to graph f of x and then draw f of x on the graph below. Well, I'm not going to use Desmos to do that, because I know my parent function is going to be 0. We did 0, 0. It's going to go through the origin, and then we can do that old 1 over 1, 149 thing. So if I put a 1 in, I'm going to get 1, 2, 3, 4. Remember, I can reflect that across my axis of symmetry. Then if I put in a 2, 2 squared is 4 times 4 is 16. So this thing's going up really fast and really steep, and it's not going to be so easy to grab, but it's a skinny little bugger like that going up, okay? Now, how do we know if the inverse of f of x is a function? Okay, well, we know this by use the horizontal line test. Okay, just like the vertical line test states whether or not a graph is a function, the horizontal line test tells us if that graph's inverse is a function. So all I really need to do is I'm going to grab a line here, and I'm just going to make it, I don't know, what color. I don't know if we can see that yellow or not, but I'm going to draw a line, and I can see that line is actually hitting in 2 spots, okay? So because I'm hitting the 2 spot, is the inverse of f of x a function? No, it is not, because that actually is going to mean it is not, it's not 1-to-1. So I'm going to put a no here, and then I'm also going to get rid of this little guy, and I'm going to delete that off. So what the next thing says, it says restrict f of x so that the positive roots only exist for the inverse. So that means only the positives. Okay, we're only going to get the positive roots out. We don't want the plus and minus out. We only want the positives out. Well, how are we going to do that? We're going to restrict the domain so it's only outputting the positive roots. Well, what that does is that looks at our vertex, and we're going to cut half of that parabola off. And the easiest way to think about this is I can split my parabola right there. This side is the positive half. This side is the negative half. How do I know that? Well, bottom line, I think of it as simply as this is the direction of the positive numbers, and this is the direction for the negative numbers. So that's what I'm going to do. So I'm going to restrict the domain so that its inverse will be a function. What I'm doing is I'm going to erase the whole left side of this guy. Now when I look at that little bugger, that little tidbit off of there, now what did I do? Well, I just restricted the domain for x's to be greater than or equal to 0. And if I did that, well, what's the range of f of x? Okay, right, the restricted, my range didn't change. It's still y is greater than or equal to 0. And what's my x-intercept for f of x? Well, I can see that's 0, 0. And I can see my y-intercept for f of x, that's 0, 0. Remember, to find the y-intercept, you put in 0 for x. And to find your x-intercepts, you set the function, you put in 0 for y, and then solve. That's how you find those. Well, if we graph it, we can look right at our graph for it. No problem. Okay, so what I need to do to make this, see, now that I cut half of that parabola off, it will be what they call invertible, because it'll be 1-to-1, and it will pass the horizontal line test. Okay, so, well, given this function here, algebraically, let's find its inverse. Well, how am I going to find its inverse? Well, first I got to switch my x's and y's, and then I need to solve for y. So the first thing I'm going to do is I'm going to square root, so I get plus or minus the square root of x equals y minus 1. And then I'm going to say y equals plus or minus the square root of x plus 1. So there is my inverse. Now notice I'm going to say y equals plus or minus the square root of x plus 1. Okay. Is there a problem using this notation right here? That means inverse. And there is a problem with that, okay? And the problem is if the inverse is not a function, I can't use the function notation that I have highlighted on there, okay? So what I'm going to do is I'm going to hit pause. I have a little bit I'm going to write in here, and then I'll read it to you, but I don't want to take too much of your time, so I'm going to hit pause. Okay, so right here, is there a problem using f inverse of x for the inverse? There is, because f inverse of x, this notation right here, indicates that the inverse will be a function, and in this case, it's not. And if you're confused, well, we're going to graph it, and you're going to do the horizontal line test, and you're going to see, oh, it's not. So bottom line, this notation right here, f inverse of x, should only be used when the inverse is actually going to be a function. Well, if I graph my original f of x function, okay, that's vertex form there. I can see I have my vertex over here at 1, 0, and I know a is 1, so I can do my over 1, up 1. I can do my 1, 4, 9 graphing pattern, 2, 4, reflected. And I can go over 1, 2, 3, up, 2, 4, 6, 8, 9, and come over and reflect over. And I can see that here is f of x. That's my function. Well, like I said, if I did the horizontal line test, that thing fails now, doesn't it? Okay, so it's not a function. That's why. That's why I'm saying it's not a function. I need to picture that. Well, hopefully you know what this graph looks like. You know it's a parabola opening upwards, and it's going to fail the vertical line test. So that's how we know that it's not going to be a function. Okay? Come on. Get off there. Delete. And now they're going to ask me some questions about the domain of f. Well, what is the domain of f? The domain of f, well, when I look at this graph, I can see my domain is all real numbers. Okay? I can see that because it covers all positive and negative x's. I can put whatever I want in here to get a y out. What's the range? Well, I can see my range is the range is y greater than or equal to 0. I can see my x-intercept here for this particular function is 1, 0. I can read it right off my graph. I can see my y-intercept is 0, 0, 1. Okay? Now they want us to restrict, because it's not a function right now. Now we're going to restrict the domain of f so that the positive roots of the inverse create a function. So it'll pass the horizontal line test. Remember, it's actually pretty easy. Here's my vertex right here. This side is the positive half of the parabola. This side is the negative half of the parabola. It's really easy to split that little bugger up. So what they want us to do is they want us to restrict the domain to create a new function. Well, if I restrict this function, now I've restricted my function. Okay, so I just restricted it for my positive numbers. So and then they want us to graph f of x. So the restricted domain that we just did is, if I'm looking here, I'm saying, okay, x has to be greater than or equal to positive 1. That's how I'm going to restrict it. Well, if they want me to graph the inverse, don't make the graphing too hard, guys. We know we have this point. We have that point 0, 0. We know we have this point of, what is that? That's 2, 1, 2, 1. We have this point that's 1, 2, 3, 4, 3, 4. And we also have 1, 2, 3, 4, 9, don't we? 4, 9. Well, if I have this graph, okay, and I have these 4 points I know, all I need to do is swap my x's and y's. So f inverse of x is going to have the point 0, 0 on it. It's going to have the point 1, 2 on it. It's going to have the point 4, 3 on it, and 9, 4 on it. So if I go plot these, well, here's this guy, and I'm going to go over 1, over 1, up 2. Hold on here. I don't have a 0, 0 in there. Come on, Kruger. That was really dumb. Oh, son of a biscuit. Need a smaller one here. So we're going to get rid of this. 0, 0 is not on there. Learn how to count. I need to learn how to count, that's 1, 0. So that means this point over here is 0, 1. So as I go make my point, it's not the one I got here. It's not that one. That was my red one, okay? That's that red little guy. So I'm going to go plot my green ones, and I'm going to plot 0, 1. And then I'm going to plot over 1, up 2. And I'm going to plot over 1, 2, 3, up 1, 2, 3, 4. And I'm going to plot over, let's see, 2, 4, 6, 8, 9. 1, 2, 3, 4, 5, 4. 1, 2, 3. What the heck is going on here? 1, 2, 3, 4. 1, 2, 3. I actually got to let me back this up. Come on, I'm getting a little nutty here. I got to go 1, 2, 3, 4. I go here. And then I'm going over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So I can see that is my inverse of it. And you can do the vertical line test on that green function, and you can see it is a function. Well, what's the domain of the green one? The domain of the green one is what? What is the domain of my green function? The domain of my green function are x's greater than or equal to 0, aren't they? And what's my range? My range are y's greater than or equal to 1. Well, check this out. Okay? Inverse functions swap x's and y's, don't they? Well, if I restricted the domain of f of x to be this, well, check it out. If I swap x's and y's, the domain becomes my range, and my range becomes my domain. Okay, so you can kind of see that. Well, what's my x-intercept for the green one? Doesn't have one, so I don't know. I'm going to put none. Doesn't have one because it wasn't there. Well, that's because I restricted the domain. And what's my y-intercept? My y-intercept is going to be 0, 1. All right? Well, my y-intercept is flip-flopping though, so you got to see your graph. And there's another very unique thing here. Remember, we can look at, I don't want a highlighter, I want my line. If I took this line right here, y equals x, okay, notice how those two graphs, they reflect right across that line, y equals x. Therefore, graphically, they are inverse functions of each other. Kind of cool. I'm going to delete that out. So what are we going to do? We're going to move on to our next problem here. And without graphing, what I want you to do is I want you to think about this. What is the domain of this function without graphing? Well, it's actually pretty simple because you see how, didn't want to do that. You see how that function has a square root on it, right? Well, what's the only thing we can't do in a square root? Well, we can't take the square root of a negative. So if x, the domain has to be greater than or equal to -4. Because if x is smaller than -4, I'm going to get a negative underneath that root, and I wouldn't be able to take it. It would be an imaginary number. Okay? So, what is my range? Well, if I think about this, when I put my small domain value in there, I'm going to have y equals the square root of x plus 4. So if I put that -4 in there, I'm going to say y equals 0. So my range is y, and my critical kind of value I'm talking about is going to be 0. And because this is a positive root, this is going to be, think of our function, it's going to kind of hook up like that. And if I put a number bigger than -4, like if I put a 0 in there, I'm going to get 2. So it's going to go to y's that are bigger or equal to 2. Okay, what's my y-intercept? Well, my y-intercept is put a 0 in for x. So if I put a 0 in for x, I get out the square root of 4, which is 2. Okay, what's my x-intercept? Well, my x-intercept is putting a 0 in for y to get x plus 4. So what is my y-intercept going to be? Well, I can think about this. What do I got to do? I got to square both sides to get rid of that, and I get 0 equals x plus 4, so x equals negative 4. So when x is negative 4, y is 0, okay? And explain how I know the domain. Well, like I said, I know the domain because you cannot, actually I'm going to hit pause, and I'm going to write it in there for you, and I'll be right back. Okay, so the explain how I know that. Well, anything smaller than x equals 4 is going to give us a negative number underneath that square root, which would mean it would be an imaginary number. We don't want imaginary numbers, we want real ones. In my range, well, how do I know the range is y greater than 0? Well, when x is negative 4, y is 0. In all other outputs that we're going to get in the domain, as x's get bigger than 4, the numbers are going to get bigger than 0, so I know my range is all y's greater than or equal to 0. Okay? Now, then you're supposed to graph this in decimals to check it out. Well, here is where my square root function starts, and it goes from there to bigger. So it's only numbers greater than or equal to negative 4 for x's, and for the y's, it starts at 0 and it goes bigger. So it's all real numbers greater than or equal to 0. So what I want you guys to do is, I'm going to hit pause. I'm going to fill in these next 2 problems, and I would like you to give them a shot, and I'll have the graphs underneath here. So just try to give them a shot. I'll review my graphs for you to make sure you did them right. So really, when we're finding the domain of a square root function or any even root function, guys, to be honest, all you got to do is you got to take that expression that is underneath the square root function, and remember that just has to be greater than or equal to 0. And when I solve that, I get my domain. And then to find my range is I will find out when x is 0, what does it output? And it outputs 0. And then I'm going to pick another value in my domain, plug it in here to see if it's getting bigger or smaller, and all of the other outputs are greater than 0. Okay? Y-intercept. Put a 0 in for x. 3 times 0 is 0. Square root of 0 is 0. Boom. X-intercepts. Put a 0 in for y. Square root of 3x and solve. So you're going to square both sides. You're going to get 0 equals 3x. So x equals 0. So what I did is I put a 0 in for y, and I solved, and I got a 0 out for x. Well, what does my graph look like? For all x here, all the x's are bigger than 0, and all the y's are bigger than 0. So it looks like we nailed that one out. Okay, the next one. X is greater than 0. Like I said, all you need to do is take the expression. It's just the x that's underneath that square root. We need to make sure what's under the square root is always greater than or equal to 0. Hey, look at that. It's already solved. Then, what I'm going to do is I'm going to put that in there. I'm going to say the square root of 0 minus 3. So if I put a 0 in, this is going to output a negative 3. So here's my negative 3, and I'm going to say y. And all I'm going to do is I'm going to pick another one greater than 0. Say maybe, oh, I don't know, I'll probably pick 4 or 1. So f of 1 is going to be the square root of 1 minus 3. Well, that's going to equal negative 2, isn't it? And negative 2 is greater than negative 3, so all the y's are going to be bigger. Y-intercept. Put a 0 in for x. That's where the 0, negative 3 comes out. The y-intercept, put a 0 in for y, equals the square root of x minus 3. Solve for x. We got to add that 3 across. And then we're going to have to square both sides to get rid of that. So 9 equals x. So when I put, wait, not that. X-intercept. That's 9, 3. That's not quite right. So it's 0, 9. So when I put a 0 in for y, I get a 9 out for x. Well, let's check this business out. And there it is. Okay, I can see my y-intercept here. I can see all x's are bigger. I can see all y's are bigger than that negative 3. Okay, all x's are bigger than 0. All y's are bigger than negative 3. I can see this y-intercept there of 9, 0. There they all are, all right? Now we're going to have one more here. And we're going to give this function, we're going to find its inverse. Well, that means this is an x. This is going to be a y to the third over 8. Well, I swap my x's and y's. So what am I going to do? I'm going to multiply both sides times 8. So I'm going to get 8x equals y to the third. And then what do I got to do? I need to take the cubed root of both sides. Now, a cubed root. Cubed roots do not need pluses or minuses, so y equals the cubed root of 8x, which is really the cubed root of 8 times the cubed root of x, so y equals 2 times the cubed root of x, because the cubed root of 8 is 2. So there would be my inverse, okay? Well, they want us to first graph this guy for us. So I'm going to come on here and I'm going to graph this little bugger quick. And remember, I can plug in here. So if I put in a 0, 0, I get out a 0. If I put a 1, well, I wouldn't want to put in a 1 for x because I'm going to have a hard time graphing an 8. So let's say I put in a 2. Let's say I put in a 2 for x. Well, that's going to give me 8 over 8. That's going to output a 1. Well, what happens if I put a negative 2? Well, that's going to give me negative 8 over 8. That's going to give me a negative 1. Okay? Well, what happens when I put something bigger than that in there? What do I want to put in there? Well, find a couple more points and see what we're going to get here. Be right back. Okay, so if we actually put 4, when x is 4, what we're going to get is we're going to get 4. We get 64 over 8, which is going to give me 4 comma 8. So my original function f is going to kind of look like this. And it's not easy to draw on here. And so we drew f, this is my f of x, is the inverse of x of f a function? Yes, it is. Envision that horizontal line test on there. So if I had a horizontal line, and I took that line and I drug it anywhere, I'm only ever hitting that graph in one place. So yes, it will be a function. So I'm going to get rid of that, get that off of there. Do I need to restrict my domain for it to be a function? No, it already is a function. So we're going to identify each of the following for f of x. Well, what's the domain? Well, I can see it takes positive and negative, so it's all real numbers. Well, what's the range? It goes both up and down, so the range is all real numbers. What is my x-intercept? Well, if I put 0 in for x, I get 0 out for y. What's my y-intercept? Well, the same as my x-intercept, because it's 0, 0. So identify each of the following for the inverse. Well, the cool thing is if I want to graph my inverse, I have this point 0, 0. If I flip-flop 0, 0, I get that. Well, this point right here is 2 comma 1, which is going to be over 1 up comma 2. And this one over here is 4, 8, which means I want 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, and I'm going to flip those. This guy over here is negative 2 comma negative 1. So I want to go negative 1, negative 2. This one down here, this is negative 4, negative 8. So I want to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. I want to go negative 4, negative 8. And I can see that that's kind of ugly, my bottom one there. But I can see also that if I drew my wonderful y equals x line through there, I can see that the red one and the green one, they are reflections of each other across that line y equals x. Graphically, they are inverse functions of each other. And the really cool thing is I do not need to see, what's going on here? I do not need to see my graph for the domain, okay? Because I did not need to restrict anything in my domain. So remember, range is y's, domains are x's. So if functions in their inverse swap x's and y's, all of these y's become x's, all of these x's become y's, and my x-intercept and my y-intercept. Oh, what do we got going on there? Well, I have 0, 0. Well, they're going to switch 0, 0. They're going to flip everything out. Nothing changed there. Okay? We're going to have one more to graph here. And it's a little bit different, but check it out. This is a cube root. Okay? If you take a negative number to an odd power, you get a negative number. If you take a negative number to or a positive number to an odd power is positive. A negative to an odd power is a negative, contrary to the squares. Okay? Everything a squared outputs is positive. So let's check this out. Except we're not going to make this 27. That makes my graph too big. I want you to change that to 8. Okay, x cubed plus 8. And we're going to find its inverse. Well, you can do this one of two ways. I'm going to graph it first this time, which means if I graphed it, I'm going to go 0. If I put a 0 in there for that, I get 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to get 0, 8. Okay? And if I put a 1 in here, so I'm just going to go x, y, and I'm going 0, 8. If I put a 1 in, I'm going to get 9 out, aren't I? So I'm going to go over 1, up 9. If I put a 2 in there, I'm going to get 8 plus 8 is 16. That's off my graph, but I can see this is kind of coming up like that. If I put a negative 1 in there, well, that's going to be negative 1 cubed plus 8. That's going to give me 7 now, so that's going to be 1 less. And if I put a negative 2 in there, well, what's that going to give me? Negative 2 is going to give me negative 8, so that's going to give me a 0, so I can see my graph is going to kind of look like that. Well, let me ask a couple questions here. Is the inverse of that red graph going to be a function? Yes, it is. It passes the horizontal line test, okay? Do I need to restrict it? I do not, because it's already a function. What is the domain of that red graph? It's all real numbers. What's the range? Well, it goes up and it goes down. From its kind of starting point right here, okay, it goes up and down from its starting point, so that's all real numbers. What's my x-intercept? Well, my x-intercept's negative 2, 0. What's my y-intercept? Well, my y-intercept was, it's 0, 8, right? 0, 8. Well, I don't need to see my graph here, guys, to get this, because it's already a function. So I know this is going to come from this. I know this is going to come from this, because they swap all x's and y's, right? And I know if I reverse this pair, it's 0, negative 2. And if I reverse this pair, it's 8, 0, right? Which means this is my x-intercept, and this is going to be my y-intercept, negative 2, 0, and those would be my points. Well, just remember, if I'm reversing these, I'm going to do this and kind of this. This one here, I'm taking that 0, 8. That means I'm plotting 1, 2, 3, 4, 5, 6, 7, 8, 0. This point right here, that's 1, 9, so I'm going over 9, up 1. This little guy right here is negative 1, 7, so I'm going 7, 1, 2, 3, 4, 5, 6, 7, down 1. And this one down here, well, that's negative 2, 0, so I'm going to go 0, negative 2. So I can see that this guy is going to kind of look like that. And even if I drew my y equals x line in here, I can see it is like beautifully reflected across that. It's a nice reflection across that. So it is a function. Okay, I'm going to delete that off of there. And then all I want you to do is, look, well, check this out. If it was an odd degree, a cubic root, the domain and range were always all real numbers. So, because I can put anything in, I can cube anything. Oh, I never got my, I never found my inverse, so I better find that inverse up here. So I'm going to have x. Whoa, didn't want to do that. Whoa, didn't want to do that. So I'm going to have x equals y to the third plus 8, which is really x minus 8 equals y to the third. Well, now I got to cube root both sides. And I don't need to worry about signs because I can cube root a positive number and a negative number. It just works the way it is. Y equals the cube root of x minus 8. So that is the pink graph. And this is the red graph. They are inverse functions of each other. But notice, The domain and range of both of them is all real numbers. So this is pretty simple. All real numbers, all real numbers. Well, how do I know? Well, because I can take the cubed root of anything. Because if I have a negative number, the cubed root of negative 8 is negative 2, because negative 2 times itself 3 times is negative 8. Okay? And I'm looking at this, so what is the range? Well, I know the range is all real numbers because as x goes to infinity, my f of x goes to positive infinity. And as x goes to negative infinity, my end behaviors, my f of x actually went to negative infinity. My end behaviors were opposite, therefore everything is there. What was the y-intercept? Well, it really doesn't take a rocket scientist to put a 0 in for x. And what is 0 plus 2? Well, that's 2. That would be the cubed root of 2, of which I do not know without my calculator. Well, check it out. There he is. That is our graph, our domain, our range is on it, and our x-intercept is there. Our y-intercept is a little bit more than 1. Okay. Last one I got for you here. Well, again, it's a cubic. That's how I know. Explain how I know. Because I can take the cubed root of anything. I can't take the square root. I can't take an even root of anything, but I can take an odd root of anything. What is my y-intercept? Well, what do I get? When I put 0 in for x, what is f of 0? Well, that's the cubed root of 0 plus 2. Looks like that's going to output 2. Okay? Check it out. Did it work? Sure looks good to me. Okay, you just graphing these, and we're graphing our cubed roots and moving up and moving down. Okay? And all we have here is there's no homework for today. Your job is to make sure these are done because you have a formative in its learning tomorrow that needs to get done. And when they're closed, they're closed. So please get them done. And we will finish this lesson on Monday. Have a great rest of your day.